we're going to talk about the Pythagorean Theorem. And to start off, we have to realize that it only works with a right triangle. And here we have a right triangle. We need to do some definitions. And one of the legs and the other leg are the two sides of the right triangle that make the right angle. And the side across from it, that's called the hypotenuse. Now, if we call the legs A and B, and we call the hypotenuse C, then we can go ahead and draw a square off of side A, and the area of that square is A squared. We draw a square off of side B, and the area of that square is B squared. And do the same technique to the hypotenuse, and if we calculated that area, it would be C squared. Through some experimentation, we discovered that there's a relationship between A squared, B squared, and C squared, and we came up with A squared plus B squared equals C squared. And that actually is indeed the Pythagorean theorem. So in order to use this, there are two places that we can use it, and those two places are to determine if we have a right triangle and the other use is to find the missing side length, and we'll do that in a few minutes. But if we're going to determine whether or not we have a right triangle, we can do an example. And that example would be if we have the side lengths 5, 12, and 13. We use the Pythagorean theorem and plug in the two legs, which are the 5 and the 12, and the hypotenuse would be the 13. So we say 5 squared plus 12 squared. That should equal 13 squared if we have a right triangle. As we do the calculations, we get 25 plus 144, and does that equal 169? 25 plus 144 is 169. So yes, we have 169 equals 169, so yes, we do have a right triangle. Now you try with the side lengths of 5, 7, and 11. Press pause and go ahead and give this one a try. Welcome back. If we try this one, we end up with 5 squared plus plus 7 squared. And we're wondering if that equals 11 squared. So 5 squared is 25, plus 7 squared is 49. 25 plus 49 gives us 74. And we want to know that whether or not that equals 121. And it does not equal 121, so no, there's not a right triangle in this example. The next thing we're going to look at is to find a missing length of a right triangle. Okay. And the example that we'll start out with is my right triangle here, a little sketch of it, where I have one side length is x, another is 15 inches, and the hypotenuse is 17 inches. Need a little bit more room. There we go. So we use the Pythagorean theorem. Since x is a leg, we do x squared plus the other leg is 15, 15 squared. And we know it's a right triangle, so we say that equals the hypotenuse squared. So we still have x squared, we don't know what that one is, equals plus 225, and that needs to equal 289. So subtract the 225 from both sides. When we do that, we calculate x squared is equal to 64. Go ahead and take the square root of both of those, and we end up with x equals 8. Don't forget to label inches. So let's have you give one a try, and here's your right triangle. Here's your right angle. And the legs are x, 8 meters, and 10 meters. Go ahead and hit pause and give that one a try. Welcome back. Let's see if you got it. We go ahead and plug in the legs. 8 squared plus x squared needs to equal 10 squared. We get 64 plus x squared equals 100. Subtract 64 from both sides. X squared has to equal 36. In order to find x, we take the square root of both sides, and x equals 6. And don't forget to label meters. Thank you for spending some time figuring out the Pythagorean theorem.